Single sideband signals. A single sideband full carrier is a form of amplitude modulation in which the carrier is transmitted at full power, but only one of the sidebands is transmitted. Therefore, SSBFC transmissions require only half as much bandwidth as conventional double sideband AM. The frequency spectrum and the relative power distribution for a single sideband full carrier is shown here. Note that with 100% modulation, the carrier power constitutes 4/5 or 80% of the total transmitted power, and only 1/5 or 20% of the total power is in the sideband. For conventional double sideband AM with 100% modulation, 2/3 of the total transmitted power is in the carrier and 1/3 is in the sideband. Therefore, although single sideband full carrier requires less total power, it actually utilizes a small percentage of that power for the information carrying portion of the signal. A single sideband suppressed carrier, or SSBSC, is form of amplitude modulation in which the carrier is totally suppressed and one of the sidebands is removed. The single sideband suppressed carrier, similar with single sideband full carrier, requires half as much bandwidth as the conventional double sideband AM and less transmitted power. In single sideband suppressed carrier, the sideband power constitutes 100% of the total power. The SSBSC requires less total power than the conventional AM. At 100% modulation, 83.3% of power is saved by suppressing the carrier and one of the sidebands. Single sideband reduced carrier. A single sideband reduced carrier is a form of amplitude modulation in which one of the sidebands is totally removed, and the carrier voltage is reduced to approximately 10% of its unmodulated amplitude. To produce a reduced carrier component, the carrier is totally suppressed during modulation and then reinserted at reduced amplitude. Therefore, single sideband reduced carrier is sometimes called single sideband reinserted carrier. The reinserted carrier is often called a pilot carrier and is reinserted for the modulation process. SSBRC requires half as much bandwidth as conventional AM, and because the carrier is transmitted at a reduced level, it also conserves considerable power. In single sideband reduced carrier, it shows that the sideband power constitutes to almost 100% of the transmitted power. Independent sideband is a form of amplitude modulation in which a single carrier frequency is independently modulated by two different modulating signals. The independent sideband is a form of double sideband transmission in which the transmitter consists of two independent single sideband suppressed carrier modulators. The output of the two modulators are combined to form a double sideband signal, wherein one modulator produces only the upper sideband and the other produces only the lower sideband. The single sideband output signals from the two modulators are combined to form a double sideband signal in which the two sidebands are totally independent of each other, except that they are symmetrical about a common carrier frequency. Independent sideband conserves both transmit power and bandwidth, as two information sources are transmitted within the same frequency spectrum as would be required by a single source using conventional double sideband transmission. Independent sideband is one technique that is used for stereo AM transmission. One channel, the left, is transmitted in the lower sideband, and the other channel, the right, is transmitted in the upper sideband. Next is vestigial sideband. It is a form of amplitude modulation in which the carrier frequency and one complete sideband is transmitted, but only a part of the second sideband is transmitted. The most widely known vestigial sideband is a picture portion of an analog commercial television broadcasting signal. In the figure, here you can see that the carrier is transmitted at full power.